absolutely watch that.
Except for Seamus. You can carry on. We're listening. YouTube's listening. We're listening. No one listens to these except for you, anyways. It's not like it's like a hot commodity. Ooh, there's a new episode of Master Guys One. I cannot wait to listen to it tonight. Riveting. Okay. So we have a pendulum 30 centimeters long, swings through an arc of 45. This is just so you know, these are very obvious because they do not fit anywhere else in the trig. Like trig, you do exact values, you solve, you do graphs, you do equations, you do proofs, you do blah, blah, blah. And then there's this weird angle swerving thing that you have. It's the very top right formula on your formula sheet. It's theta equals A over R. Oops, that's successful. Nope. R is radius, you got that. A is arc length, theta is your angle. So this is your angle. And it always has to be in radians. So the trick to these is they'll either give you the angle in degrees and you have to convert it to radians, or they'll ask for the angle. It's the very top right.
Can you write it on our test?
No.
Or do you use it?
It's what you use for your test. Why would you write on it?
Okay. Well, yeah.
Come on, children. No. Did you write it in pencil?
Yeah.
Then no.
Here, I have a big eraser. Okay. I'm ready to sit on the test counts. Okay.
But then there's remnants. Ooh, you just radius really hard, and then I couldn't erase it off. It just left behind. I know, but that's not smart. If she was smarter, she would have etched it in there. Just kidding, don't do that. Okay, so they'll either give you the angle in degrees, and you'll have to convert it to use the formula, or they'll ask for the answer in degrees, and you'll have to convert it to get the answer. That's usually how it is, because the formula has to be in radians. If you put it in degrees into the formula, you will get an answer. That answer will be on the test. It will be completely wrong, but it will be there for you. So don't forget. So angle in radians. This A here is your arc length. Doesn't look like an A. Arc length. And then this is your radius. So often they'll give you diameter. And then what do you have to do to get radius? Half it, divided by 2, times by half. So, not a hard formula. It literally has 3 variables. You have to fill in 2, solve for third, right? The hardest part about this one is remembering that theta is in radians. So we have a pendulum, 30 centimeters long. It swings through an arc of 45 centimeters. Through what angle does the pendulum swing? So, my radius is what? My radius is what? It's 30. Oh, crud. This is the circle, right? It goes off the page, it comes back. What now?
How would they say that,
They couldn't ask the question the way this one is.
Okay.
Because this is center to edge, so it's the radius.
Yeah.
Right?
Oh, yeah, I get that.
They'd have to give you the diameter is,
Okay.
or they'd have to give you a circle with a diameter drawn, because they can give you a diagram too, right? The question can't be asked like this if they're actually giving you the thing. Okay, so we know R is 30, we know A is 45, and they want us to find theta. So theta equals A over R. So we do theta equals 45 centimeters over 30 centimeters. Now, if you forget what theta is in, think about it. The units cancel off. When I have theta equals something without units, what is it? Radians. Because if it was degrees, it would have to have a degree symbol, which it doesn't have. That's why this is always in radians. So theta equals 1.5 rads, or just 1.5, or 3/2, or 1.5 radians. Doesn't really matter. That's theta. They'll often have these because they're word problems. They'll often have it as a 1.5 instead of a 3/2. Now, what if they wanted it in degrees, which is most often what they do here? Radians to degrees. Already pop. Radians to degrees. Pi on bottom. Or if you go degrees to radians, pi on top, it's just the opposite. So type that in. 1.5 times 180 divided by pi. To the nearest tenth. 85. Theta equals 85. What? Point. Decimal. 9. What do I need? Degree symbol. You try B.
When you write 1.5 times 180 over 5, you have to have the degree over the 180 for it to be degrees later. You know what I mean?
Yeah, they don't inspect it. It's not like in physics where you have to have your units or chemistry and they have to cancel off and it equals. Yeah, they don't do an inspection. Yeah.
Do you have to convert meters to liters?
In part B?
No.
No, it's in meters. They don't like, they're not like physics and chemistry where they'll give you like meters and you have to convert it to centimeters for your answer. I've never seen something like that. I really hope they never do that.
Conversions of like centimeters to inches. It should be like, this is what you can memorize, and never once to have these centimeters to inches.
You can in real life though.
Yeah, isn't it?
Okay, so this one we have to calculate the arc length. Given the diameter is 9.2 meters, which means I have the radius, which is 4.6 meters. The theta is 150 degrees. Degrees to radians, Dr. Pot, degrees to radians. Pi on top. And what would you get?
Over 6.
Remember, these are ones that are directly off your unit circle, right? You wouldn't even have to convert them to your unit circle beside you. Because 150 is 5 pi over 6. Any 30s, 45s, 60s, right? Those are all on your unit circle, 35, 45, 60s. Reference angles, which we'll talk about today. Okay, so we have theta equals a over r. I need to solve for a, so I'm going to multiply by r. So a equals 4.6 meters times 5 pi over 6. So what is that to the nearest tenth? 10.0? Well, that went differently than I heard. Meters. Okay. Here's where we're learning. This is definition day. Welcome. Welcome to definition day. D squared, I'd like to call it. I just made that up. Okay. Coterminal angles. Did you guys talk about coterminals last year? Okay. Coterminal angles are angles that terminate on the exact same arm, correct? So if you're in degrees, what would you have to add in order to land back onto that arm? 360. Or you could subtract 360 and you'd land on that terminal arm. Infinitely many times forward, infinitely many times backwards, and you would terminate on the same thing, correct? If you were in radians, instead of adding 360, what would you add? 2 pi, or you would subtract 2 pi infinitely many times, and you get coterminal angles, angles that terminate on the same arm. Now, if they terminate on the same arm, you will get the same exact values from them, correct? Because the exact value, go to your unit circle for 1 second, go to your unit circle, the exact value of cos 150. So go to 150 and give me the exact value of cos. Negative root 3 over 2, correct? Now, if I subtract 360 from 150, I'm going to get negative what? Negative 210, correct? Negative 210 actually lands on that exact same arm. So what's cos of negative 210? Negative root 3 over 2, same answers. So coterminal angles will always get you the same answer because they terminate on the same arm. That's the key part of it. Okay? So coterminal angles are angles with the same terminal arm. Principal angles are your angles, the smallest positive rotational angles. So they're the ones between 0 and 360. Those are your principal angles. And then reference angles are the acute angles between the terminal arm and the x-axis. These are the ones we talk about most, this one and this one. We end up turning our angles into principal angles because they're easier to deal with, but we don't talk about it as much. But reference angles and coterminals we talk about a lot. Reference angles are the angles between the terminal arm and the x-axis. I always call them the bow tie angles. Why? Because if I have an angle here, it would be this angle, would be the reference angle. If I had an angle here, it would be this angle, which would be the reference angle. If I had an angle here, this would be the reference angle. If I had one here, this would be the reference angle. And what does that form? A bow tie. If you're trying to make hourglass angles, so if you like supplemented here and here, you'd make an hourglass, you're not doing reference angles, and those are of no help to you. The one's going towards the y-axis. So your reference angles are always towards the x-axis. And there should be between 0 and 90, right? Because the only way you'd get a 90-degree reference angle is if it was either on 270 or 90, correct? Other than that, the reference angles are going to be smaller. That's why they're acute angles. So let's sketch these. I want the reference angle and then 2 coterminals. So we do 60. Okay. How do I sketch it? Well, I label 0, 90, 180, 270, 360. Now keep in mind, if the question is in degrees, your answers, reference angle and coterminals, better be in degrees. Right? So I go to draw 60. I have my initial arm, I have my rotation, and I have 60. And I have my angle. And I label this 60. What do we notice about this one? What's the reference angle? So in quadrant 1, what are my reference angles? The angle, right? So let's look at this up here for a second before we go and do these. If we're in quadrant 1, so say we're 60, we're in quadrant 1, your reference angle equals your angle. So any angle in quadrant 1 is your reference angle, right? What about quadrant 2? So say now I have 120. How do I get my reference angle? Yeah, so when you're in quadrant 2, you always just do, to get your reference angle, you're going to do 180 minus your angle. Right? So if I go 180, in this case 180 minus 120, it's 60. We've got 60 here. So in quadrant 1, your reference angle is your angle. In quadrant 2, your reference angle is always 180 minus the angle. In quadrant 3, what's your reference angle? Pardon? Theta minus 180. Because you want to just get this little angle in here. So if I take 240 and I subtract off 180, I'm going to get 60. Right? So in quadrant 3, your reference angle is always theta minus 180. And then in quadrant 4, how would I get my reference angle? How would I get this little one? Yeah, 360 minus theta. So in this case, it'd be 360 minus 300 equals 60. The reference angle doesn't change how you find it in each quadrant, right? Quadrant 1, it is the reference angle. Quadrant 2, it's 180 minus theta. Quadrant 3, it's theta minus 180. And then quadrant 4, it's always 360 minus theta. Because you always want the little angle between the x-axis, right? Okay, how do I get a coterminal here? So I have the reference angle as theta. How do I get coterminals? Add 360. So we could go 60, theta equals 60 plus 360, which is 420. I could add another 360 to that. And it's going to be 780 degrees. Those are both coterminal, are they not? Because you'd start on this arm, and I'd rotate 360, and I'd end up at 420, and then I'd rotate another 360, and I'd end up at 780, but ultimately I'd still end on that arm. Correct? Yeah.
When you draw it, do you just draw it, or do you have to make like this spiral?
You'd have to make this spiral if you actually drew 420. So if you went to draw 420 degrees, I would start here. I would go around a whole 360, and then I would end here. Yeah. 720, you just go around again and then end there. Now I didn't do a negative one because I don't. If they ask me for two coterminals and don't tell me what I have to give, I can give whatever I want, right? So I gave two positives. Now, how do we know? People will say, well, then how do I know which one it is? If it's a multiple choice, you're going to have to add 360s or subtract 360s till you get one that matches a multiple choice, right? Because they could put whatever they want. They could put the third positive 360 or the third negative 360, whatever they want. So let's sketch 5 pi over 3. Now, sometimes sketching them is really hard if you have no clue what the heck they are. So what's the first thing you could do? Because it's easier in your head to sketch. Convert it to degrees if you wanted to. Or you could look on your unit circle, see if it exists, right? So I'm going to convert it to degrees just for practice. So we get 5 pi over 3 is 300, I believe. Remember, this is why you would draw your unit circle every single time you have a test, because it takes you a bit of time to draw it, but you can look how much faster it would be than converting that. I would just go look, 5 pi over 3 is here, sketch it, right? Off my unit circle. So it's at 300. How do I get my reference angle when I'm in quadrant 4? Ooh, I did not label these. I just labeled that 300. Come on, Lepp. Grab a mitt. Get in the game. It's radians. So it's a sketch 5 over 3, and I write 300. So, yeah.
If your angle is given in radians, but that's your sketch, can you still label your degrees?
No, you'd have to go 0, pi over 2, pi, 3 pi over 2, 2 pi. So if it's in radians, you have to draw it in radians, you have to write it in radians, yeah. So we could go 360 minus the theta, but the theta is actually in radians, isn't it? So instead of 360 minus, we would use 2 pi minus 5 pi over 3. Now we can make them have common denominators. So we could go times 3 times 3. Theta equals 6 pi over 3 minus 5 pi over 3. So it's pi over 3. This would be reference angle. The way you can check it is you can type in 2 pi minus 5 pi over 3 into your calculator without the pi's. The moment you put them in with pi's, will it turn it into a fraction? No. So try into your calculator, go 2 minus 5 over 3 in brackets. 2 minus 5 over 3. So type in the original without the pi. So 2 minus 5 over 3 in brackets. Yeah.
Do we like draw the arrow around? Do we have to write like theta equals, or do we just put like what it is?
5 pi over 3?
Yeah.
It doesn't matter.
Okay.
Because we don't actually have like a theta or anything, so we don't have, if you actually do write theta equals, you have to say let theta be the angle 5 pi over 3, and then write it, because we don't even have a theta. So if you go 2 minus 5 over 3, math enter, you're going to get a third, aren't you? Then you add the pi back. That's how you can check your math. Put it in without the pi. So that's my reference theta. Now I want two coterminals. I'm going to be a rebel, and I'm going to find the negative ones this time. Rebel. So 5 pi over 3. And in this case, I'm going to subtract 2 pi. Which is going to land on negative pi over 3. Does that make sense? Let's think about it. Okay. Oops. I'm going to start here, and then I'm going to go to there. What is that? Negative pi over 3, isn't it? Yeah, it's accurate. And let's find another negative one, just because I'm a rebel. So we can go negative pi over 3 minus 2 pi. Any common denominators again if you want to. This is going to be negative pi over 3 minus 6 pi over 3, which is negative 7 pi over 3.
Do you care if you write it like to the second one, or like does it matter if you just go 5 pi over 3 minus 4 pi for the second one?
5 pi over
Like
3.
it still gives you the same thing. It's just like you're not going from the.
Yep. I get what you're saying. Yep, totally fine. Minus 4 pi minus 6 pi minus 8 pi. Yep, totally. Okay, you draw C, draw D, draw E, draw F. See how you do. My hint to these ones, when you go to draw them, is possibly find their principal angle first. How do you find the principal angle for negative 2 pi over 3? You just add 2 pi to it, right? But you can just sketch it as well. Just try it out however you want. Try and sketch them. And we'll go through them. All right, so if we have negative 2 pi over 3, we're going to go 0, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Negative 2 pi over 3 is the same as what? Sixth degree, 120? I mean, yeah, 120. Negative 120. So negative 120 would be like 30 more than 90. You can use the degrees to draw it to help you, correct? You can convert it to a degree to help you. And remember, if you want to convert it to a degree, you can. Radians to degrees, pi on bottom. So I would multiply by pi on bottom, and I get negative 120. You can do that to help you out. I only can draw them in radians because I've had the unit circle memorized in my head for way too many years. But if this was Crystal in high school, I would probably have to convert them all to degrees. Or go to my unit circle, because this is one on my unit circle. Remember that, this is something to note. Remember that whenever they have a 3 on the bottom, a 6 on the bottom, a 4 on the bottom, or a 2 on the bottom, they're on your unit circle. Because remember, pi over 3 is a 60, pi over 6 is a 30, pi over 4 is a 45. Now, there's very few things that radians are great for. Like, normally I'm like, yeah, I get you. Radians are stupid. Like, I understand. There are two. One, word problems you need radians for. Two, you can get reference angles really, really easily, and you probably didn't even notice. Your reference angle for radians is always whatever's on the bottom, put a pi on it. So, pi on top. So if it's over 3, it's pi over 3. So if it's over 3, my reference angle is going to be pi over 3. If it's over 4, my reference angle is pi over 4. If it's 6, my reference angle is pi over 6. Because you end up having just the little reference angles of what they are. So that's one of the greatest things about radian measure is you can get your reference angle really easy. Other than that, word problems. And fun, right? Good. So this one here, because it's 60 degrees, like this is at 120, it's going to be 60 degrees to get me my reference angle to get me to here. Or you can say, hey, it's pi over 3. Because I can just go pi minus 120 in positives. My reference angles from there. Like I said, in radians, it's easy because it's just pi over whatever this is, right? So if it was negative 2 pi over 7, I don't even know what that is, but I know its reference angle is pi over 7. Bless you. Then to get coterminals, you can go negative 2 pi over 3 plus 2 pi, which is 4 pi over 3. Or you can go negative 2 pi over 3 minus 2 pi. Like I said, you can put them in your calculator without pi's, or you can make common denominators. So it'd be negative 2 pi minus 6 pi, which is negative 8 pi over 3. Then we have degrees. It usually brings great joy to people's hearts when they see a degree. Didn't know you liked them as much till this moment. That's how it is. 0, 90, 180, 270, 360. If I was like, hey, no Christmas presents, but your diploma's all in degrees, I think you'd give up your Christmas presents. Yeah. But I yeah.
Why would it pi over 3 and not negative pi over 3? Like,
Your reference angle is always a positive angle, and it's always the acute angle. So if it was that, it would be negatives can't happen. So reference angles always have to be positive. Yeah. So it's always your positive angle between 0 and 90. So we have 300. And then your reference angles from here to here, or 360 minus 300. So my reference theta is 60. And then coterminals, I can go theta equals 300 minus 360 and get negative 60, which makes sense because that would just be from here to here, right? It should terminate on the same arm. If you draw all your coterminals, you should be able to draw them and they land on that arm, right? If they can't, you mess up. And then 300 plus 360 equals 660. The catch here is I could have done 2 negatives, I could have done 2 positives, I could have added 720 to it, right? Like I could do whatever I want as long as it terminates on the same arm, which is why we're going to go down here after and talk about general form, because general form gets you the coterminal angles for everything in the entire planet, like every coterminal angle. It's the general term, general form for it. So if we go negative 135, we go 0, negative 90, negative 180, negative 270, negative 360. Negative 135. Is your angle from here, it's 45 more than 90, which is also 45 less than 180. So this is my reference angle, right? My reference angle is the bow tie angle, the angle from the terminating arm to here. So my reference theta equals 45 degrees. That's really tiny. Theta. And then to do coterminals, we could do theta equals 360 minus 135, which is 225. Try that again. 135 plus 360, which is 225. I know it works the other way, but it's dicey. And then negative 135 minus 360, negative 495. And then 750, we would literally have to go like 0, 90, 180, 270, 360, and if you could, you could keep going, 450, and keep labeling, 360, 720, 750, so what's my reference angle? 30, just from here to here.
Are you supposed to read it as like reference and then the little theta sign or like the little angle sign when you write it?
It's fine, either way. Often they'll label it like theta equals or x equals or whatever it may be, and you just go with it. Like I said, they don't often ask you to just draw an angle. We draw an angle to get actual answers. That's what we're doing for. And then coterminal, we can go 750 minus 360, which gets me positive 390, and then 390 minus 360 gets me 30. So you know that the key thing actually with coterminals a lot of the time is they'll give you an angle that doesn't fit on the unit circle, but we need answers that are on the unit circle. So like if I gave you 30 and I asked you cos of 30, you could go to x of 30, give me an answer, we're done, right? Or if I give you 150 and I say sine of 150, you could go to the y of 150, answer done, right? But if I give you like 750, you're like, oh crud. But what you can do is you can subtract 360 till you get a standard principal angle that falls between 0 and 360 and just get the answer to that, right? You just want to find a terminating arm between 0 and 360 because it's way easier, or 0 and 2 pi because it's way easier. So if they ever give me an angle that's outside of my principal angle, it's outside of 0 or 360, or 0 and 2 pi, I just subtract 2 pi's or add 2 pi's or subtract 360s or add 360s till I get it to land on the unit circle. Then I can give answers like this, right? Because it just lands on it. Or if you can find out what terminating arm it lands on too. So we're going to give the general form solution. The general form solution is basically every single angle, every single coterminal angle, every single angle that could possibly land on there. Like here, I just gave you 2 random ones. I gave you 2 added, 2 subtracted, 1 added, 1 subtracted. Just gave you random coterminals. They can ask for the general form. So we're going to look at 6a. 6a is in degrees. So I'm going to give my general form in degrees. Okay? And how I start my general form, always off, I'll show you down here, is we're going to go theta equals your principal angle so it's always your angle between 0 and 360. So if it's not between 0 and 360, you're going to find that angle, right? And then if it's in degrees, we're going to add 360 degrees, which you told me we do that, right? That was an agreement. We can add 360, or we could what? Subtract 360. So I'm going to go add 360 degrees. So that's all they ever do. They go principal to angle plus 360 degrees n. N being something that they multiply by. Okay? So if n was 1, let's say, I'd find the first positive coterminal angle, right? Because it'd be 360 times 1, so I'd add 360. If n was 2, I'd go 360 times 2, which would be adding 720. If n was 3, 360 times 3. If n was 4, 360 times 4. So this is, n is like an infinite thing, right? We use a variable to cover everything. Now, what if we want to go in subtraction? We're going to have to multiply this by what? -1 and -2 and -3 and -4 and -5 and -6, right? And if I make this be a 0, what do I get? Just the principal angle, right? So if I use 0, positive 1, 2, 3, 4, 5, 6 to infinity, -1, 2, 3, 4, 5, 6 to negative infinity, I'll actually get every single angle that would terminate on that arm, correct? if n was 0, 1, 2, 3, 4 onwards, 0, -1, -2, -3 onwards, right? What numbers are 0, 1, 2, 3, 4, 0, -1, 2? Integers. So all we have to do behind this is go semicolon or comma, they don't really care. N is an element of the integers. And you've covered every single thing. Sorry, Andre, did you have a question?
That was going to be my question.
That was gonna be your question.
You have to specify.
Yeah. Now, if your original was in radians, the only thing that would change is what? Yeah, it'd be plus 2 pi n NEI. So the hardest part is literally just finding the principal angle. So in A, what's my principal angle? 60. So I'm going to go theta equals 60 degrees. And because it's in degrees, I'm going to go plus 360 degrees N NEI. And we're going to do general form later for actual answers as well, not just coterminals. So it's only with coterminals you add 360, subtract, like, you know, add 2 pi's, because that's making you land on the same terminal arm. So what would B be? What's my principal angle for B? It is 5 pi over 3, right? It's the one that lands between 0 and 2 pi. 5 pi over 3 does. Negative pi over 3 doesn't. So it has to be the one that lands between 0 and 2 pi. So it's going to be theta equals 5 pi over 3. Plus 2 pi n NEI. C. That's my principal angle for C. It's not negative 2 pi over 3 because that's this way. I didn't even label it. What is it? I added 2 pi here and I got 4 pi over 3. That's the one that lands, that's on your unit circle, right? Because it lands between 0 and 2 pi, so this is your principal angle actually. So we're going to use theta equals 4 pi over 3. Plus 2 pi n. Anyway. You do DEF quickly. If you finish those, you can type these into your calculator and get me to 3 decimal places. What's the catch? Sine of 30 degrees I need to be in 3 mode. Sine of pi over 6, it's in radians. Sine of 1.57 radians, there's no degree. And then cotan 70, go to your formula sheet and see if you can figure out how to type that in because you don't have a cotan button. But on your formula sheet, you might have something at the very top right that can help you out because you do a tan button, you just don't have a cotan button. And we'll go through them. So D is 300, that is the principal. So 300 plus 360 degrees N, NEI. E, it's negative 135, so the principal is actually 225. It's this one. So theta equals 225 degrees plus 360 degrees N, NEI. And then 750, if I subtract the first one would be 30. So theta equals 30 degrees plus 360 degrees N, NEI. And carrying on. So when we go sine of 30, we type it into our calculator, we get negative, nope, we get 0.8660. Oh, I was doing 60. I'm doing 60. Oh, it's the excessive amount is. Sine of pi over 6. You should get the exact same answer. Why? Pi over 6 is the radian measure of 30 degrees, and we're just taking the y value off, correct? And the y value at 30 degrees is a half, right? The y value, or the x value, so if I said cos of 30, your answer would be 0.866, because it's root 3 over 2. Sine of 1.57, what's that? Pardon? 1.000? Why?
Well, yeah, 0.9999996. Yeah.
But why?
That's what
Okay, go pi divided by 2. I'll lead you into it. Go pi divided by 2. Because that's what it is. Truth that. What's pi divided by 2?
Whoa, wow.
Blah, 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 blah. This is just a rounded version of pi over 2. And what's y at pi over 2? What's y at 90? 1, because it's a radius. Cotan is 70. So I said to you, okay, this one, there is no cotan button. But I said, maybe you could go to your unit circle and say, no, unit circle, nope. Maybe you could go to your formula sheet and look, hey, I can't type in cotan, but I do have the buttons sine, cos of 10. We agree? I have those 3 buttons, that's all I got. So I look up here and I'm like, okay, so I could go cotan, I could go cos of 70 divided by sine of 70. I could do that, sure. I could go into my calculator, cos of 70 degrees divided by sine of 70 degrees. It tells me that. I could do that. There's also one lower. Look, what's cotan? Cotan equals 1 divided by tan. So I could just do that. I could just go 1 divided by tan of 70, couldn't I? Either way, you get the right answer. But I need to be in what mode? Degrees. Okay, I'm going to tell you one thing. This is what I tell everyone. Before you touch that sine, cos, tan button, you slap your hand and you're like, dude, am I in the right mode? Because so many people will get questions wrong because they're in the wrong mode. Scariest thing is when someone at the beginning of the test says to me, what mode do I need to be in? And I'm just like, oh, this is going to go poorly. Because there is no mode set, right? You could be radians, it could be degrees. It depends on the question. If I say that to them, then and their heart sinks. Their heart sinks. I don't want you to be there. I don't believe you will be there. I believe you know what you're doing. So we see, I go to press that button, I slap my hand immediately, and I'm like, dude, it's called reinforcement. It's like what they do with the mice. You slap your hand and you're like, wait a second, what do I need to be in? If you're like, what mice? They always, don't you hear all the things about mice, Pavlov's mice and stuff like that? Like, they do stuff where if the mouse goes up to go drink water, they'll zap it. And then it doesn't want to get, Pavlov's dog. That was the drooling, wasn't it? Yeah. Then, no, but there are mice where they'll like, Pavlov probably owned the dogs, but we don't know. Okay. But there's mice, and you'll reinforce whatever. If you zap the mouse a whole bunch of times, the mouse will do what you want it to do. If you like, that was the same thing with the dog, right? Same thing with you. You slap your hand, and now people be like, right, mode. Mode. Mode.
So should I stop hitting my microphone?
That is not at all where we went. No. Did you know that there's bark collars? People don't really like them. I'm sure people would not be happy with it, but there's bark collars. Do you bark on a regular basis? Do you need a collar? I don't think there's bark collars.
If I just get my brother,
No.
I'll start.
No. We're taking it to a whole new life. Okay, what's the answer to this? 1 divided by 10 is, you guys took this to a whole new level. I told you to hit only your hand, and that would fix the problem. Okay? Not other people's hands. 0.364.
Can I like clap?
No. Well, you can do whatever you want. You don't have to slap yourself. I don't really care. I'm not promoting you hitting yourself either. Like, you could just lightly just tap. You could just be like, mode. Okay, stop hitting yourself. Okay.